It's the pinnacle of the Artemis II lunar flyby mission. Day 6, and the crew of 4 will be going around the moon. For 40 minutes, they'll be out of mission control's range. They'll also be breaking the record for furthest distance by humans from the Earth, set by Apollo way back in 1970. Emerald Maxwell has more.
It marks a milestone in the mission, where the moon's gravitational pull is now stronger than Earth's.
We are now falling to the moon rather than rising away from Earth.
The 4 of us have looked at this moon our entire lives, and the way we are responding to what we are seeing out the window is, it's just like we're a bunch of little kids up here. We cannot get enough of this. It's amazing.
The Orion capsule is now gearing up for its lunar spin, where its 4 astronauts, 3 Americans and 1 Canadian, will go further from planet Earth than any human before. This picture taken by the crew shows a sliver of our home planet through the window of the spacecraft.
It's a bit dark inside the spacecraft because they've turned off the interior lights to provide a better environment to capture some of those images.
The crew has also been tasked with taking detailed photos from the dark side of the moon.
You see on the left side a list of sort of targets that listed vertically in the top left of the screen. Those are the targets in the timelined order we're asking them to image them in.
Beginning 6:45 p.m. GMT, the 6-hour flyby takes advantage of Earth and the moon's gravity, reducing the need for fuel. It's the highlight of NASA's first return to Earth's natural satellite since the Apollo era, a step towards landing near the moon's south pole in just 2 years.
And joining us live from Toulouse in southwestern France, headquarters at the European Space Agency, is Didier Schmitt, coordinator for future exploration projects at the ESA. Thank you for being with us here on France 24.
Good afternoon.
You heard that clip of one of the astronauts saying they're like little kids watching what they can see, and the best is yet to come.
Yeah, it must be quite amazing. 53 years after Apollo. Yeah, the best is to come because they will be for 6 hours. They will be so to say mapping the far side of the moon that no human eye actually has seen before. So that is quite fascinating.
And we'll be talking with you about the importance for scientific research of this mission. Again, there's also going to be, some 40 minutes where there'll be no contact with Earth and with mission control at Cape Canaveral. Is that for you? Does that give you the jitters, or it's all fine?
Well, let's say these kind of things have been tested, of course, obviously before. Indeed, there will be what we call a blackout because the moon will be, so to say, in between the spaceship and Earth for 40 minutes. That will start 1:45 midnight this evening for 40 minutes. So the spacecraft will be on its own. But anyway, the spacecraft is pretty much automated. So computers are, let's say, handling the spacecraft. The mission is a test mission. So a lot of things will be tested, and this is part of it, of course. And why don't we have a relay satellite yet behind the moon? It's because nobody has landed so far except the Chinese robotically. So they could have a relay satellite, but the US doesn't have one.
We're starting to get the first images now from NASA showing the moon. And again, we call it the far side of the moon. It's a mistake to call it the dark side of the moon, since this is the side that's always exposed to the sun. People forget that. For you, what's the biggest significance of today's pinnacle of this mission?
Well, the number one, so to say, is that they made it. So to say, they made it to the moon. They did the flyby. Between now and in 6 hours from now, they will be turning around the moon. Actually, only the moon gravity will bring them back. So there's no major engine firing and so on, because this is exactly why we do this flyby in that mode, so that we don't need to use the fuel on board. And you see here on the left side, European Service Module. So it's the top contribution of Europe to this mission. When you see the solar panel, this is the module which carries the Orion capsule. So we're all proud in Europe and in the US, of course. That's the first time since Apollo that the US has opened up, so to say, a significant part of the collaboration, technical collaboration, to go back to the moon. So we're quite proud to be part of it.
Yeah, tell us more about how you divvied up the work between NASA and the European Space Agency.
Yeah, so when we say Orion module, it is the capsule, so to say, where the 4 astronauts are living in. And behind it, there is a module called European Service Module. So the service module has these solar arrays, so it does provide the energy to the spacecraft, but it also provides the life support systems, so the water, the air, and it does the propulsion. So which is actually this module brings the spacecraft to the moon and brings it back. So that's quite fantastic for us. It does all the attitude controls which have been tested during this flight. And just to remind you, it is a test flight, of course, to land on the moon in the coming years.
Yeah, they can land on the moon by the year 2028 is the target. Will they meet that target?
Well, I leave this up to them to respond, but that's the target that they have, and they will be working quite hard to do this. So after Artemis II, there will still be a test flight this time around Earth for the docking with the landing systems. So that will be quite an extraordinary mission as well. And then hopefully Artemis IV will be the first landing again after Apollo.
Now, they're going to be going at some 6,500 kilometers from the surface of the moon. As you said, they're in the moon's orbit and they're using the moon's orbit to travel, to propel them for now. But they won't be getting close. Just to give you an idea, Apollo 13 in 1970 was 110 kilometers from the moon. Why so far away from the surface?
Yeah, of course, Apollo 13, I mean, the spacecraft was different. And of course, well, it was an emergency mode to fly around the moon and use the gravity of the moon because they had real issues with propulsion of their spacecraft. That's why they couldn't land with Apollo 13. So why so far? Actually, it is orbital mechanics. It depends on the mass of the vehicle and the speed of the vehicle. The speed is quite amazing as well. It's over 11 kilometers a second. So all this is calculated via computers and corrected if needed by the pilot so that the gravity compensates, the moon attraction compensates the speed of the spacecraft to bring them back without firing any engine.
And then once they've finished their orbital run around the moon, they'll be using their jet propulsion to get out of the moon's orbit.
Well, they don't really need much. They will do attitude controls because they have to be extremely precise when they come to Earth with the angle of re-entry to Earth. That's the critical phase. There are always two critical phases in these type of missions. One is the launch, which was perfect. And the other one is, of course, insertion into Earth. And you can imagine, as I said, over 11 kilometers a second entering Earth, the heat shield needs to be quite resistant. It needs to resist to more than 2,500 degrees. So that will be, the end of the mission in less than 4 days.
So when they go to the far side of the moon, which will be in the next 2 to 3 hours, they will be having a look at what's called the Orbital Basin. Why is it important for humans to be setting their eyes on this?
Well, no, I mean, there was a spacecraft before which has done this. So the Chinese did land on robotically on the far side, but the imagery that we have is not very good. So this time they will be able, with the naked eyes and of course with a very with cameras which have extremely high resolution to map the surface. So the mapping has not been done at this distance yet. So this will be quite interesting to do also for scientific reasons, because this side of the moon has been bombarded quite significantly also by, as you can see here on the image, by meteorites. But the far side and the side that we see permanently are very different geologically. So the scientists will be quite interested to have some high resolution imagery.
What will we learn about planet Earth, knowing that the moon was part of the Earth at one point? So what will this teach us about our own planet?
Yeah, this maybe not much for the time being, but once we land again, of course, obviously we're already working on quite significant scientific programs. What is interesting is and different from the Apollo program is that this time the landings will be on the South Pole. This is where there are craters which have been shielded from any sun since millions and millions of years. So the off-gassing of the of any material, gaseous material from the moon has been trapped at about minus 200 degrees in these shadow areas. So this will be the challenge to get samples, moon samples from that region, which will tell us how the moon evolved from something which was nearly volcanic some billion years ago to something that apparently today is a dead body, but it is not. The core is still quite hot and does some off-gassing, which is interesting to analyze.
And why did we need to, if we're doing a manned mission around the moon, why did we first need to do a fly around before landing?
Well, you need to test the systems. I mean, the Artemis I did nearly the same, but without a crew on board. This time, the pilot and the co-pilot, they have the 6 days to test all the systems, the life support, of course, the attitude control. And the attitude control, by the way, is also done by the service module made in Europe, by the European Space Agency. And all this needs to be tested because when they will go back to the moon in Artemis 4 and 5 to land, they need to master completely the spacecraft. So the only way to do it is to do this type of test flights.
And there'll be those 40 minutes where they're incommunicado. They'll also be, will they be more exposed to the sun's ultraviolet rays? Is there a danger of any kind for the capsule?
Not at that stage, because the UV shielding is done by the spacecraft. That's not a big issue. Of course, there will be a blackout of 40 minutes, so later today before midnight. So, of course, it is stressful, maybe not for the crew, because I think they will be watching the moon constantly, but for the communication or the teams in Houston that follow the mission, including European Space Agency teams, it will be a little bit stressful, because if you don't hear anything for 40 minutes, you hope that everything is in order when they're back in with a link. But we expect that nothing special will happen, hopefully.
And one final question. You mentioned earlier how the other point of suspense will be re-entry into to the Earth. That's in 4 days' time. It's a long journey back.
Well, long, yes, but still, the speed is still the same. It's over 11 kilometers a second. The moon is quite far away, 385,000 kilometers. So that's the time it takes. So you can imagine what will happen when we go to Mars, which is 1,000 times more.
Wow, 1,000 times more. Didier Schmitt, is there a 24-hour team in Toulouse watching it the way there is at Cape Canaveral?
Yes, they're not in Toulouse. They're actually in the U.S. and there is one a team also in Darmstadt as well, and there are teams in the Netherlands. So we are spread around Europe. Correcting one thing: the headquarters of ESA is in Paris, not in Toulouse. In Toulouse is the headquarters of the French Space Agency.
Right, thanks for that correction. And Didier Schmitt, it's 10 enthralling days for everyone watching all of this. I want to thank you so much for joining us here on France 24.
Thank you for your interest. Goodbye.